So you may tell me that, oh, why are you writing the question? You could have just given the options and the screenshot of the question. I didn't do that just to make you think in the process, okay, what I'm writing, and you are thinking in the process. That's what I'm expecting from you.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
IIT 2023, problem number 2. So what does this problem talk about? So this problem says that if you have two 3 cross 3 matrices, M1 and M2, both are 3 cross 3, just to remind you. And if you take another matrix that is calculated using this, multiplying these two matrices together, naturally, this is 3 cross 3, this is 3 cross 3, the output will be a 3 cross 3 together. For this matrix, two statements are being provided. Number one, it is said that the rows of M are linear combinations of the rows of M2. And the second option, the second statement is the columns of M are linear combinations of the columns of M1. So these are the two options, rather two statements given regarding this problem. Now, naturally, the four options, because understand this is another kind of question. So there are two statements, and both of them has two options, either true or false. So I'm not writing down the options. So the goal is there for the problem to understand that whether one is true or false, and two is also true or false or not. So there are many multiple ways to solve this problem. Let me discuss a very simple, straightforward method. What you can do is the following. You can just write down a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33, and similarly another matrix B1, B2. This is M1, let's say, and another matrix B1 where this is being, or let's make it dash. This is M2, and then you multiply it and you get a result of the AIs and the A dash IJs and the AIJs, and correspondingly comment of the truthness of this statement above. But as you can see, you can surely get the answer from there. That is one way out. But this is clearly not an elegant way out. Like, elegance is something that you can really see through, like a lens when you put a magnifying glass in front of your eyes. So what can be an elegant way of understanding the solution? The answer lies in what is an elegant way of combining, understand the answer. So this is the problem solving steps and strategy we all talk about. We glorify it. Then the next question is, the question is all about this, understand this is matrix multiplication and understanding its relationship of the rows, rather the rows of M2 and the columns of M1. So you have to somehow connect the matrix multiplication with the rows of the individual rows and columns of the individual matrices. So this is what the problem is trying to make you understand or make you think about of individual matrices. So this is right at the face, staring at you, that the problem is wanting you to understand, rather interpret the matrix multiplication, not in this element-wise way, element-wise, not in this fashion, because that will not lead to a proper, quick, or elegant solution. You want to see through the problem. And so it's asking you to understand or find the relationship between the matrix multiplication and the rows and columns of the individual matrices. Okay, so how to proceed with this? I am talking from the very scratch, okay? So therefore, I'm taking some more time instead of just spitting out the solution in front of you. So let's rewrite the entire matrix in terms of this rows and, or rather matrix multiplication in terms of this rows and columns of the individual matrices M1 and M2. So it's asked that the rows of M is a linear combinations of the rows of M2. So let's write the rows of M2 first. So it's M1 comma M2. So M1, M2. So it's mostly about the rows of M2 and the columns of M1. So let's write that in that way. So you can see this matrix, this is the column vector. This is called a column vector. This is called a column vector, right? And let's call this C1, C2. C denotes the column, and this is the row 1. This is now the row vector, you can see. Let's call this R1, R2, and R3. And when you multiply this, it looks like the following. Rather, M is, you can now rewrite is it as C1, C2, C3. These are vectors, remember that, multiplied by R1, R2, R3. So this is how it looks like right now. Also, this is what the problem is all about. It has boiled down to because it was concerned about the rows of M2 and the columns of M1. So what's next? What's next about understanding whether the rows of M are a linear combination of the rows of M2 or not, right? So let's focus on that question. So let's focus on now the rows of M2, how it is computed. So if you observe how is the row and the column multiplication is individually computed. Let's observe this very carefully. So let's take a small example. How do you really do this matrix multiplication of these rows and columns together? So if you observe this, let's take a 2 cross 2 example. Let's say there is this 2 and you have these columns out there. We want to understand the rows of M2 and the rows of M. So let's think about it for some time. I'm giving you some moments to think about it. Understand, you have to find out how the multiplication is done in terms of the rows and the other elements of M1 to get the rows of M. So this is what you wanted to understand. So it's very simple. If you just write this as, let's say, R1 and R2, this row is kind of like, so I'm just drawing these lines again to make you understand. So it's like this line times this number plus this line times this number is this line. Do you see that? How to understand that? Because you can see that you can observe this way. This is where the beauty of the vectors come up. It's kind of 2 cross 2, let's say here. And even if you have this just as a 1 point number, if you observe the 2 cross 1, then it will be nothing but this times this plus this times this. That is another point you get. But instead of this point, you have lines now, like the above. So the red times the red scalar number times the red vector plus the blue scalar number times the blue vector. That will give this new row vector. So how do you really write this down? You write this down as, so let's now do it for 3 cross 3 because you understood the whole idea, because it's generalizable to 3 cross 3, right? So for 3 cross 3, you can see that this will be, let's do this like this, multiplication and addition. So how do you write this down? So if this is A11, A12, A13, and this is row 1, row 2, and row 3, so let's write it on a proper way. A11, A12, A13, A21, A22, A23, A31, A32, and A33, and it's multiplied by this row vectors R1, R2, R3. You can see this new row vector will be nothing but, let's call it R1 dash, will be nothing but A11 times R1 plus A12 times R2 plus A13 times R3. It is aligned in perfect order. Similarly, the R2 dash will be A21 times R1 plus A22 times R2 plus A23 times R3, like this similar fashion. And the R3 dash, the third row of M, will be A31 times R1 plus A32 times R2 plus A33 times R3. So you can be asking, oh, it's already solved, then what's the point of just writing it from scratch again? The reason is we want to write it algebraically so that you can generalize this idea for n cross n matrices. So R1 dash can be written as, observe that what is common here. How do you write it in a summation? These are the fundamental things that builds up your foundations, right? That's exactly what Cheenta focuses on. That's what exactly the mission of Cheenta is. So that's why we focus on the small foundations of the aspects. So you can see this 2 and 3, this A1, this one, this 2, 2, 3, 3. So how do you write it down? You can see that it's nothing but summation of, and you can see 1, 1 here, 2, 2 here, 3, 3. So it's already Aij, but the sum is going over the j because of the second part. It's this part is where the sum is going on, not the I. So it's j from 1 to 3 Aij times Rj. Okay, that is what the Ri dash is. You understand? So this is the row ith row of M matrix is, and this is the jth row of M2 matrix. And this is how the entire equation is formed. And you can see easily that yes, each of the rows of M or I dash is nothing but a linear combination of the rows of M2. Similarly, you can solve it for M1 perspective, but in M1 perspective, it will be columns instead of rows. Let's try out that. So now you have the columns of the matrices C1, C2, C3, and here let's again call it let's do this copy paste thing. This is the M2 part. So yes, so C1, C2, C3. Now this is the M2, this is the M1. You want to write it in terms of the columns, right? So observe that C1, C2, C3. Now let's write it again. Write as if assume these are as if scalars and do the matrix multiplication in that same way. So essentially we have reduced the calculation from 3 cross 3 in terms of, this is nothing but 1 cross 3, right? If you just write C1, C2, C3, it seems like as if it's a vector of 1 cross 3. So that's the whole idea. We are reducing the computation of 3 cross 3 times 3 cross 3 to 1 cross 3 times 3 cross 3. So that's the goal of the problem, to help you understand that yes, if you just represent this whole vector as a single variable, algebraic variable, the matrix multiplication still goes ahead. And it's exactly because it will turns out to be 1 cross 3 times 3 cross 6. This is the reason behind it, why this is actually working. I'm repeating once again. If you just reduce down this individual group of numbers, vectors, so single algebraic variable C1, C2, C3, it's as if you are doing 1 cross 3 multiplication with 3 cross 3 multiplication, which is give rise to 1 cross 3 again. But it's algebraically. Under the hood, this C1, C2, C3, these algebraic variables are actually vectors. Okay, this is the beauty. This is the beauty. This is happening because both the real numbers and both R3, both are vector spaces. That's why it's happening. Otherwise, you couldn't have done it. Okay, because of the linear properties of the vector space. So C1, C2, C3, we are reducing, those are columns, the algebraic values for the columns. So now it's again, you can see it's very similar. So it's C1 times A1 dash. So let's write it directly summation. Now observe that here, this one, the first one is changing. Okay, C1 times A dash 1 1, C2 times A dash 2 1, C3 times A dash 3 1. So here summation is over AI, and here it is CI, but here the summation is over 1 to 3. This first one is A1. The second one is this J1 is the 1. The next one will be AI2. The next one will be AI3. CI, summation. So yeah, so you have seen here again that each of the columns are nothing but, again, each of the column of M1, M is nothing but a linear combination of the columns of M1, right? So what is the crux of the problem? And similarly, you can extend it to n cross n matrices. It's true for n cross n matrices. So what's the crux of the problem? The crux of the problem is in this. We are reducing down. The goal of the problem is to make you understand that matrix multiplication can be viewed also as a 1 cross 3 or 1 cross n vector times a matrix, the times scalar multiplication, right? So it's not just element wise, but also you can view it as vector wise. And that's the lesson from this problem. Matrix multiplication can be viewed as vector times scalar 2, and their linear combination, summation. This is the goal of the problem. I hope you understood this problem. Now I will open the floor and to your doubts, guys.
To book a trial class for your preparation courses of IIT GEM MS, ISIM Stat and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.